Okay, so so now here when you get down to this one, we are looking at the first and foremost we look at the capital budgeting. So capital budgeting, okay, this one is also called investment appraisal technique. Investment or project evaluation technique. All right. So the techniques that we use here, all right, there are actually 5 techniques. We have the NPV, which is the net present value. So this one is called net present value. Then we have the payback period. Okay, so payback period is the second technique. Then we have the internal rate of return. Okay, so internal rate of return. We of course have the accounting rate of return. Okay, so accounting rate of return. So if they ask you to talk about the techniques that are used in capital budgeting, these ones: net present value, payback period, internal rate of return, accounting rate of return, and of course we have what we call profitability index. Okay, the PI. So these are the techniques that are used in capital budgeting. Now, what is the acceptance criteria? Okay, acceptance criteria before you look at the question that we're going to do. Accept project if NPV is greater than 0 for NPV. Okay, so this is just simply the sum of present values of all cash inflows. Okay, the minus initial investment in a project. Initial investment, okay, in a project. This is about what NPV is all about. And this NPV uses time value of money. Okay. So NPV uses what? The time value of money. Okay. That is what happens here. Then we have, and of course, it uses the original cash flows as they come. Okay. So you're simply saying this one uses original cash flows as they come. Okay. And then what is the other one? The other one is that in short, this NPV does not account for profit. Does not account for profits. Okay. So these are the theories to do with NPV, and this is one of the common methods that we use in project evaluation technique. Okay. And of course, now we can get down to the other aspect. The other aspect here is where we look at the payback period. Okay. What is a payback period? This is simply the time taken to recover the exact amount invested in a project. Okay. So this is just time taken to recover the exact amount invested in a project. Okay, invested in a project. Okay, so now what happens here is that you accept a project with a shorter payback period. Accept project with a shorter payback period. Shorter payback. Okay, payback period. Then the one of the weaknesses of this one is that, okay, of course, people looking at the weaknesses, we look at this one, is also considers original cash flows as they come. Cash flows as they come. Of course, this one also does not account for time value of money. Does not account for time value of money. Okay, so this is the weakness, and of course, okay. So we are getting down to these ones. So time taken to recover the exact amount based on the project, nothing more, nothing less. Accept the project with shorter payback period. Then of course it consider cash
Yes,
flows as they
sir.
come.
How are you? Nakuona kwamba chizungusha.
Okay. I'm sure we are getting down to something. Then it ignores other cash flows after payback period. It ignores other cash flows after payback period. Okay, so this is about what goes on. Okay, and we can look at now the internal rate of return. So internal rate of return. This is just the return that investors expect as a result of making an investment in the project or in a project, in a project. Okay. Then accept project if internal rate of return is greater than cost of capital. So this is the acceptance criteria. Then this one uses time value of money. Okay. And of course, considers cash flows as they come, considers cash flows as they come. Okay. Now, these can be the strengths or the merits. Then on the disadvantages, you say it ignores profit. It ignores profits. Then the other one, not easy to calculate. Not easy to calculate because it uses um, chooses two NPVs and two rates. So as you can see, the formula for internal rate of return in the exam to be provided, I'm sure it's A1 plus NPV1 over NPV1 minus NPV2. Okay, then B2 minus A1. Are we together here for this one? Are we together so far? So for B2, you need to set the rate as high as possible. That is for rate 2. In order to get negative NPV2. Okay, so set the rate as high as possible in order to get what? Negative NPV2. This is what happens here. So you need to accept the project if internal rate of return is greater than cost of capital. Okay. This is time value, this is time value of money, consider cash flows as income. And of course, notice to calculate is one of the its advantages. Okay. Okay, so now this one, it is computed based on trial and error. The internal rate of return is computed based on what? Computed based on trial and error. So this is just about what we have. So in this class, we need to concentrate on these three project evaluation. But of course, I can also explain the PI, profitability index, okay, what this index is all about. So this is simply the sum of present values of all cash inflows, okay, then divide by, so divide by what? Divide by initial investment in a project, initial investment in a project. Okay, so our PI is equal to sum of present values of all inflows. We're talking about of all cash inflows divided by initial investment. Okay, in a project. So accept project if the PI is greater than 1, otherwise reject the project. So otherwise reject the project. So this is what happens concerning the PI. I'm sure we are together so far, unless there are questions before we move on. Okay. Are there questions so far? Are there some questions? Excuse me, are people following me so far?
There are no questions so far.
Okay, thank you very much. So now so these are the techniques that we use in capital budgeting for the sake of the question that we are going to look at right about now. Okay, so you appraise an investment. Is it worthwhile? Is the project viable for you as an investor when you want to make an investment in a given project? Now, let us get down to the question. Okay, so the question we are getting down to, okay, go down to the question. Okay, so question 3 of this paper. So this question says, okay, let's look at this question 3 together. So question 3 says what? DISA Limited, okay, actually is considering which of either of the two mutually exclusive projects to undertake. Okay, so a mutually exclusive project simply means a project that has nothing in common. Okay, that is mutually exclusive. And of course, the expected cash flows for the project you've been given here. Okay, so we have the year uh, 0, 1, 2, 3, up to 5. Okay, so now the question here says we need to now check here. So every time when you're making an investment, you are making an investment at time 0. So that's what happens. So we always invest at t is equal to 0. This is when we make an investment. At time 0, an investment is made. All right. So now, so this is what we call initial outlay occurs. Initial outlay occurs at time 0. Okay. So now, the two projects that we have actually been given, let's now check which project is viable. So the year 0, we made an investment of 1,000 in project P, and then of course 10,000 in project Q. All right. And then what happens here is that we have actually gotten these years. Okay, so for project P, we have 1,000. That meant 240 came in, 290 came in as a cash flow, and then 340 came in also as a cash flow. It is in year 3, 410 came in as cash flow in year number 4. Now, as I come to, let I use my whiteboard here. Of course, whatever it is, I'll just go an extra mile. So if we look at this project, project P, okay, you made an investment at year 0, 1, 2, 3, 4, 5. So the investment is done at year 0. So we have actually gotten these values, okay? So here we have a 1,000 that was made at this year, and then the 240 came in the year 1 as a cash inflow. When you see a negative value, just know that that's an outlay, okay? That is an outlay or an expenditure, okay? Meaning that money is actually going away. So what would be our payback period for this project? Okay. Yeah, I know this question was not asked, but I have just incorporated it. So the payback period simply means how long it takes for us to recover the amount that we invested in the project. Now, you can see that we invested this much. Then we have recovered the 240 in year 1, 290 year 2. How much is it in total? You can add the 240 plus the 290 is giving us the 530. 530 plus 340, quite all right. will be 870. So when you add these 240 plus 290, okay, then plus the other one, which is the 340, we are getting the total value of 870. Now, this 870, if we add the 410, it will bypass the 1000. So meaning our payback period will be 3 years for now, then plus the 1000 minus 870, which we will recover from year 4, okay, for year 4 or 410. Are people with me so far? So it will be 3 years plus, what's the difference there? 130, right? Which we can recover from a 410. So what are we getting now? So the answer is 3.3 years. That's the payback period for this project. Is it clear so far? If they ask you to find the payback period for this project, is that okay? Are we safe? Calculating the payback?
Yes, we're together.
Okay, if you're behind, please feel free to ask questions.
No questions.
Okay, thank you very much. Let's see, move on now so that we can sort out the other one so that we see what the payback period will be for the other okay, the other project. So for the other project, okay. So for the other project is project number Q. Okay, so for project Q, assist me as we get down to this. What will be the payback period? So here we are the year for Q, we invested at 10,000, 2,300 came in as a cash inflow. The 2,600 came in. The 3,000 came in as a cash inflow. The 3,500 came in. The 4,000 came in. These were the cash inflows. Okay, so we can move on now. Okay, so this is on project Q. So we had a year 0, 1, 2, 3, 4, 5. Okay. So we made an investment, and of course we have a 10,000 here. Okay, and there's a 2,300 that came in, a 2,600 that came in as a cash inflow, 3,000 came in as a cash inflow, 3,500 came in, 4,000 came in as a cash inflow. So now, what is our payback period? We need to recover how much? Exactly 10,000. So you should say a 2,3 plus a 2,6 plus a 3,000. What amount are we getting here when you add face those ones? We should not surpass the amount that we are looking for. Okay. So it's giving us 7,900. So meaning, should we add the 3,500? No, because it will bypass the 10,000 that we need to recover. So our payback period will be, so payback period for this one is actually equal to, first of all, it's 3 years, then plus 10,000 minus the 79. This amount will recover it from year 4, where we have a 3,500. So it will be 3, then plus 10,000 K minus that, which is 2,1 divided by the 3,500. So 2,1 divided by 3,500 plus 3. It's giving us 3.6 years. So 3.6 years. So this is the payback period for this project Q. So you make comparisons. So in case of what you need to do, you're interested in the shorter the payback, the better appraisal technique that you can go for as we evaluate the viability of a given project. All right, now we can get down to the question here, where we're looking at these two projects. Of course, they didn't ask us to find the payback period, okay? But of course, they have given us two projects, and they are just telling us that the projects are in the same risk category, and there is up capital rationing. And of course, they are saying that the cost of capital is 10% for the projects, okay, of this type. So now, when they give you the cost of capital, it means that as you find the present values of cash flows, okay, use the present value interest factor. Okay, this is a present value, okay, interest factor table. These are the ones that we actually use. So if we are getting the rate, so the PV, okay, IF simply means it's 1 plus R to the power negative N. So this is about what we need to use. So 10%, it simply means 0.1, okay? And of course, it is 1.1 to the power negative N. So N can be N number. So you can say 1.1 to the power negative 1. It will give you the 1.1 to the power negative 2. So you can get the financial tables that they'll give you at the end of the question paper. 1.2 to the power negative 3. You can get 1.2 to the power negative 4. You can as well get. All right, so you can use the what? You can use these ones for you to get the present values. All right, so now getting down to the solution, okay? We can just now, yes, the first one says calculate the net present value of each project. These projects, they have nothing in common. They are mutually exclusive. They are disjoint. Okay, so calculate so the fact that you would select project P, there's nothing in common as you select project, the other project, because of the mutual understanding. There's mutually exclusive. There's a mutually exclusive. They are not. There's nothing in common. Okay, so this is just about what we have. So now what we need to do is okay. So we need to sort out this one. Okay, and the okay. Okay, so I don't know if you're able to get me. Are we together? Okay, so meaning that as we are finding as we are getting down to the net present value for project P, you come here and use the rate. The rate that you use is 10%. So the rate we are using is the rate is equal to 10%. Okay, so now this 10% is what you're using here. So multiplying by the cash flows. So 1.1 to the power negative 0 is 1. 1.1 to the power negative 1 is 0.909. And then 1.1 to the power negative 2 is 0.826. 1.1 to the power negative 3 is 0.751. And then, of course, 1.1 to the power negative 4 is 0.683. 1.1 to the power negative 5 is this one. So you multiply this one to get the last one. You multiply this one to get the last one. You multiply this one to get the last one. You multiply these two to get the last one. You multiply to get the last one. Is that okay so far? Hello?
Yes, it's
Yeah,
fine.
that's clear.
Uh, Okay, so there's no problem. We will share the recording. So you add all these ones, these values, minus how much you invested. So we're getting the NPV is 272.52, right? The sum of the present values minus initial investment in the project. So it's giving us 272.52. You add these ones here minus how much you invested. Is that okay with you?
Yes.
Okay, fine. Then getting down to project Q, you do the same, using the same rate. Okay, so n number raised to the power negative, to the power 0 is 1. So we multiply this one by this to get the last one. We multiply this one to get the last one. We multiply this one to get this one. We multiply this one to get that one. We multiply this one to get that one. We multiply this one to get that one. So you add this one, this one, this one, this one, this one. The sum of the present values of all these ones minus how much we invested. So it's giving us 1,635, that's 1,365.8. So meaning you go for a higher NPV in this case. Okay. So this is what the first one is all about. You find the what? You find the NPV for each project. You have the 10 marks there. Okay. And of course, we now calculate the internal rate of return for each project. Calculate the internal rate of return for what? For each project. So if you see what I explained earlier, I mentioned that our internal rate of return, the formula is actually, this one uses two rates. Okay, so the formula for internal rate of return is this one. It uses two rates. So the first rate A is the original rate that they give you in the question. In this case, we have what are we having? In this case, we have the 10%. Okay, so we have the 10%. That is the initial rate. Then the rate 2, you need to set for yourself. So you go to the present value interest factor table. Check in the PVIF table. Okay, check in the PVIF table. Okay, so check the PVIF table and select, okay, the largest possible rate from away from 10%. So you can even use it. So this is our A1, 10. Then our B2, you can get a 20% or you can get a 25%. Okay, from the table. Okay, so this is what is happening there. Okay, so now we can now go for the other one. So for project Q, we found the NPV for Q, which is the 1,365.8. I'm sure you are able to see this one also. Is that clear?
Yes, it's great.
Okay, now so now we get into the internal rate of return for for project A. So we are going to use this one. We use interpolation. So we have the first rate is A1, and then the other one is NPV1. Able to say NPV1 here? Yeah, NPV1. So meaning that as you come to as you come here, we looked at our internal rate of return. We said it's equal to A1 plus NPV1 over NPV1 minus NPV2, then B2 minus A1. You're able to see my whiteboard?
Yes.
So A1 is rate 1. Okay, so rate 1 in this case was 10%. And then getting down to B2, you can set the rate as high as possible. So of course you can actually look at, in this case, I use a 25%. So use the largest possible rate that will give you in the present value factor tables, the discount factor tables. okay, to get, and try by all means to make sure that don't use a rate that is as close as possible to the initial one, because you still get a positive one. Here, for internal rate of return, the NPV2 should be negative. So the higher the rate, so NPV2 should be what? Should be negative. Okay. So,
Mm-hmm.
so when you get a higher rate will give you the smaller NPV. So higher rate will give you negative NPV. Higher rate will give you negative NPV, which is the negative net present value. So in this case, I use okay, in this case I used what? I used the 25%. So I have to find 25% using the same. So if you get a calculator, you would see 1.1. So it is 1 plus r to the power negative n. Okay, so r rate is 25%. So it will be 1.25 to the power negative 0 is 1. So we multiply the 240 by this amount to get the last amount here, the last column for the present values. Then 290 multiplied by that to get that one. This one multiplied by this, you get that one. Then this one multiplied by that one, you get that one. 450 multiplied by this one, you get this one. So the present NPV is the sum of the present values of all cash inflows, which are these ones, then minus the initial investment in the project over 1,000. So it's giving us a negative NPV. Okay. So if we had used a 15% as rate 2 here, it would have given us a positive NPV, which would have made you now to go again to use another different rate, like 20% to find another one. So you end up wasting time in an exam. So you use the largest possible rate from the table, okay, the last value of the discount rate from the table that they have given you for you to get the okay, the net NPV 2, okay, which would be negative in every other case. So we have NPV 2, this is for project P, all right. Now, when you check the NPV for project 1, initially it was 272.52. You understand that?
Yes.
Now we are getting the NPV 2 now for project P is negative 132.928. So of course, substituting using the formula here, we have gotten negative or negative. This one, as you multiply negative or negative, will give you a positive. All right, then the 272.52, and of course, divide by this one, multiply by the difference between here is 0.15. All right. So when you multiply these two, 272.52 divided by 405.448, okay, times 0.15 is giving us that one. So it's approximately 20%. That's the internal rate of return for a project number A, all right? Then we're building up a little bit. Okay, so building up a little bit, we are getting down to okay, the internal rate of return for project Q. The initial NPV for Q was 1,365.8. All right, and then we are using the same rates, 25%. These figures are just the same as these ones here. Okay, so we are now getting down to okay, multiplying these ones. So 10,000 by 1, you're getting that amount. This one by 0.8, you're getting that amount. This one by that, you're getting that amount, even this one. So we are simply saying that the net present value here for project Q is just, okay, is negative 2,215.68. Okay, then internal rate of return, we substitute 1,3, this was NPV1, okay, then this is NPV2. So substituting these ones, we are getting 0.1, then the other end here, you are getting, but multiplying, this is an addition now, which is giving us 3,581.48, then multiplied by the difference in this end is 0.15, and we're simply getting down to approximately 16%. All right. So, okay. So, based on NPV, you need to just invest in project Q with higher NPV. And since both projects have internal rate of return greater than cost of capital, you can choose either project for internal rate of return. Choose either project for internal rate of return so for NPV, okay, so in short here, for NPV, choose the project with higher NPV. Okay, so for NPV, choose the project Q with higher NPV. But for internal rate of return, you can choose the project what? Project A with higher internal rate of return. So based on internal rate of return, you can choose the project A, this one that has a high internal rate of return. But on NPV, it is project T, project B. Okay, so now the question is asking us here now, they're saying, okay, discuss which project should be selected when mutually exclusive projects are of the same risk type and there is no capital rationing in the above case. So here, we can just select either projects based on the criteria that will favor which project. Like in this case, if it's for NPV, you need to choose project Q. Okay, are we together so far?
Yes.
Yeah, so NPV, you choose project Q. That is for based on NPV. And of course, based on the internal rate of return, you just say, if it's based on internal rate of return, you choose the project A. Okay. When you're an investor, your technique that you would want to use, if it's NPV, you choose the one with higher NPV. If it's for the internal rate of return, you choose the one which has a higher internal rate of return. So this is basically how you need to sort out this question. Is that okay with you?
All right. Okay.
Okay.
Uh,
Yes.
a question.
Uh-huh.
Yes. On the when you're substituting on the formula for IRR, this percentage that we put, do we like I've seen here, you have change them to decimal places. Do you have to, when you put them like the way they are, can they give you the same one, or they will give you the wrong one? Like for A and the B,
Uh,
I'm saying when you're calculating for internal rate of return on the formula there, when
uh-huh.
you substituting the um, A and B, because
Uh-huh.
I've seen like most of the question they convert them to decimal places, like
Yes.
the way I've done here.
Uh-huh.
Now I'm asking if if we put them just like that without converting them, will you get the same results, or they will give you the wrong answer?
No, it's okay. If you put 0.2.
No, no. Like for example, here where I put 0.10, you put 10% instead of that. Then there where you put 25%,
Here
you have a 0.
here you put 10% and here you put 10% here.
Yes.
No problem. They will still mark you correct.
Okay.
No problem. It's just those are percentages. They will still mark you to be just still correct.
No, okay.
You get the point, right?
Yes, I get it.
Okay, okay. So I'm sure you have understood this question. So I'm sure it is well. Okay, so this is all. This question has to do with it. This has to do with capital budgeting. Now, I'll give you a question to try so that in the next class we'll be able to look at a question. Okay. So here,
Okay.
it is question 2. Have you seen this question 2?
Yes.
It says Dangote Limited is considering a capital investment project costing 560,000. The project will generate future cash flows as follows. Year one, we have this amount. So meaning, as you sort out this question, you need to find we first and foremost, we cannot straight away go to the internal rate of return. First, you need to do what? You need to do you need to do what? You need to first of all find the NPV one, right?
NPV, yes. Yes.
Then you also need to find NPV2. So you need to find how many NPVs? Two NPVs. So the first rate is 15% that has been given in the question. And of course, so the rate is 15%. I'm sure you're able to see it, right?
Yes.
So question 2, you can see this question 2, okay? This is a question here. So I want to, so have you seen here, it was 15%. So 560,000 by 15, so 15 the same as 1 plus r to the power negative n. So 1.15 to the power negative n. So you multiply these ones by that one to get the last one. This by this to get the last one. Then this one by this to get the last one. This one by this to get the last one. This one by this to get the last one. This one by this to get the last one. So the summation of present value of all these, that's NPV1, right? Are we together?
Yes.
This one, this one, and this one, and this one, add minus that one. So the NPV was 27,932. Okay. Now using the highest possible rate to get the negative NPV, I use the 25 or 30%. So you can use the, so 35, so I use the 30% instead, so that, because if I had used maybe 25, it would have given us another positive. So I thought of getting down to the highest possible value. Okay, so 30%. So I got a negative NPV here. Okay, by adding all these minus the initial investment in the project, right? Are we together?
Mm-hmm.
So we got this amount as NPV2. So NPV2 is giving us this. Then rate 1 is 15%. Rate 2 is a 30% or 0.3. Then substituting here, we got the internal rate of return of 21.5. Is that okay with you?
Yes, fine.
Okay, so this is what happens in capital budgeting. So this is the only toughest question that we can experience in capital budgeting to do with internal rate of return, because it requires two rates, and as well as it requires the two NPVs. Now, my question is, from the way we've looked at this question, of course you can have the year 0, 1, 2, 3, 4, 5. So you have the cash flows the same way they are. So 560,000. You have 170,000 as a positive way, 180,000. Then you have a 200,000. You have a 250,000. You have 160,000. So what will be our payback period for this one? How long it will take for us to recover this amount, right? So how much have we recovered year one? You have recovered
Okay.
170. Are we together?
Okay. Let me just calculate a bit.
I give you time.
Yes.
Find for me the payback period for this one, if you
Okay.
can.
So
So what answer are we getting?
So it will be 3 point. Let me see. By 2.06.
Come again?
Oh, 3.06.
3.0. Okay, so it will have first 3 years. Then plus, we have how much is remaining. So yeah, this is for 3 years, you are getting 550,000, right?
550.
Then it will be 560 minus 550, which will recover from where? The 250 also.
Yes.
We have 250. Thank you very much. 250,000. So meaning this will be 3 plus 10,000 divided by 250,000. So 10 divided by 250 plus, you said the answer is what, 3.04?
I found something like 3.06.
No, there is a 10,000 here, not so, which will recover from a 250,000. It's 3.04 years. Just divide
Okay,
10,000
so it is 10,000 divided by
by 250.
250, right?
Yes,
Okay, yeah, it's 0.04. So
plus
it's
3.
3.04.
Yeah,
Yes,
so this is how we find the payback
3.0.
period. Is that okay?
Yes, fine.
Now, there is the other thing that I need you to know is that when you are finding from this same question, if you are asked to find the PI, the profitability index for this question, the PI, what would be a profitability index? Sum of present values divided by initial investment. Initial
Okay,
what?
so let me,
Investment.
yes.
So meaning what is our sum of present values? You add all these ones here. 147, 832, okay? All those present values, this one, this one, this one, this one, and that one, all right? All together.
Yes,
So the answer is giving me 630 what? Giving me 637, 637, 932. Then divide by how much we invested was 560,000. 560,000. So what are we getting? So divide by 560,000. You're getting 1 point what? 1.139. So I told you to say that accept the project if PI is greater than 1. Otherwise, reject the project. You get my point, eh?
all right.
So this is it, what we go for. So payback period we have covered in this case. In this case, for the sake of this class, we've covered at least the 4 techniques. We have covered the NPV. We have covered the internal rate of return. We have covered the payback. Okay, and we have covered also the PI. So we end here for now. All right.
Okay. I don't know if I can ask for
There's no problem.
not based on this question. I just want guidance on the abilities. How do you assume that? Do you get that the probability is one or all of them? Or
Okay, so what you do if they have given you the state of the economy, you have a question. You have a question with you.
yeah, it's in the laptop now. The laptop is done.
Oh, okay. So,
But the question is
so boom.
like
So check here, boom.
uh-huh.
So if it's booming, it is a
Uh-huh.
normal. and it is in recession, an example, okay? Recession, okay? And then maybe no growth, no
Okay.
no growth here. So meaning that if the probabilities are not given, you just say it's 1 out of 4, which is 0.25. That's the probability we use.
Or 1 out of
1 out
4.
of four scenarios.
So if you are given 3 scenarios, then it will be 1 out of 3.
Correct. To find the
Okay.
probability. 1 out of 4. I don't know. If you have the question paper for which year was it?
This year,
Is
okay,
it
let me try to find out.
was it this year or it was the last year?
It was this year.
Oh, okay. This year,
Yeah.
well, this year we haven't written the exam yet.